Hello friends, welcome back to my YouTube channel MS Maths. In this video, we are going to discuss the acceleration of the fluid. In the previous video, we have already discussed that what is the velocity component. So basically, the velocity component is q vector, that is u I cap plus v j cap plus w k cap. Then we can also write this velocity component as u, v and w. So basically in this case, in this lecture, we'll discuss the acceleration of the fluid. So consider a fluid particle traveling along a curve C and let the position of the fluid particle is P at time t and is specified by a position vector OP is equals to r vector and its velocity is q vector along this, that is basically ui cap plus vj cap plus wk cap along the target at P to the curve on the C, and then the direction of the particle motion, then the instantaneous acceleration of the particle at P is denoted by F. So basically the acceleration is basically the derivative of the velocity with respect to time is denoted by F here. So it is dq vector over dt. Okay, so this will be the partial derivative of the q vector with respect to the partial derivative of the t plus q vector plus delta into q vector. So we can write it as in this way, that dq by dt is nothing but dou q vector upon dou t plus q vector into delta into q vector. Now what is the meaning of this? Basically in this case we can find the velocity, we can use all like these to like a relation to simplify the value of the acceleration. So dq vector upon dt is basically the dou q vector upon dou t plus q vector dot del q vector. Okay, so in this case it will be d by dt and u I cap plus vj cap plus wk cap is basically the velocity component q vector is equals to dou by dou t is ui cap plus vj cap plus wk cap plus u, like basically this is the dot product of q and del is basically u del over del x plus v del over del y or w dou over dou z into I cap, vj cap and wk cap. So this will basically the du by dt. Now on comparing this side, that du by dt is basically dou u by dou t, the coefficient of I cap basically, plus u dou u by dou x plus v dou u by dou y, okay, plus w dou u by dou z. How is it? On comparing the I cap, on comparing with I cap and after multiplying with this, okay, this component will get multiplied with this and this, and after comparing the coefficient of I cap will get this, okay, on comparing the coefficient of I, j and k cap. Similarly dv by dt is basically dou v by dou t plus u dou v by dou x plus v dou v by dou y plus w dou v by dou z. In the similar manner, that we'll have dw by dt is basically dou w by dou t plus u dou w over dou x plus v dou w over dou y plus w dou w over dou z. These are the acceleration components. So now we have as the q vector dot del into q vector is nothing but the summation q vector dot I cap is del q vector upon del x. Okay, we can write in this manner. Now, what is this? Okay, like this is basically we can write in this way, like instead of writing all I, j, k, we can write in the compact form. It is basically the q vector dot b vector into c vector. So what is the formula for this? To c vector. So the formula for this is basically the a vector into c vector into b vector minus a cross, or basically like the formula is basically in this way that this is the formula from vector calculus. A vector cross b vector cross c vector is basically a vector dot c vector into b vector minus a dot b into c. This is the vector triple, vector cross product triple of the like for three vectors. So we have this, we can consider this way, we have this. Okay, like a vector is basically q vector, b vector is I cap, and c vector is dou q vector by dou x. Then a vector dot b vector into c vector is basically the a vector dot c vector into b vector minus a vector cross b vector cross c vector. So this will be the summation, or it can be written as q vector dot I cap or dou by dou x is basically a vector dot c. What is a? Is basically q vector into del dou dot q dou q vector upon dou x into I cap minus a vector cross b cross c dou q vector over dou x. So this will be the expression. So we can replace that basically the summation on applying summation, on applying summation. So we'll get the summation q vector dot I cap dou q vector over dou x is equals to, by applying the summation we'll get for this is basically dou, because we'll apply the summation for I, j and k. So instead of writing the summation here, this will be del, or basically del q vector square, or 1 by 2 in this case we can write del I cap. Okay, this is I cap, then I to I, it will be 1 by 2 q vector square minus q vector cross del cross q vector. This is basically the after applying the summation, and when we apply the summation, this represent the q dot q vector dot this del into q. So this will be q into q, basically q square, and it will be half for this. So this represent when the flow is equipotential, like del dot q vector is equals to 0. Now f will be, what is your f? Is basically dou q vector over dou t plus del 1 by 2, this value 1 by 2 q vector whole square minus this q vector into del cross q vector. But flow is potential when flow is equipotential, that we have already written, this thing will be 0. So basically this will be F is dou q vector upon dou t plus del into 1 by 2 q vector whole square. So this is that physical significance we can already also consider here, that we have this curve or this surface. This is basically the surface and the fluid flow in this way. Now this is the point P, this is the point P, then the normal vector is basically in this way. This is the normal vector n cap and the velocity is basically q. Okay, this will be the flow like in this way, flow, then it will be q vector, or it is u, the component u, v, w, u, or I say it is z, then w, and it is v or y. Now in this case moving y, like in this case that q vector dot n cap is basically the u dot n cap. Okay, so this is the result for this, and this is the acceleration of fluid. So this is all about the acceleration. Now in the next lecture we will discuss further topic, pressure of the fluid at rest and at motion. So thanks for watching my video. Keep watching MS Maths, and thank you. Bye bye.